Alright, so the STM32 system workbench is installed now in this location in my PC, and in order to launch the application, so you just have to launch this application. So that is actually an Eclipse application. Now let's double click on this, and it is now getting launched. And here you can see that, so when you try to launch Eclipse or any Eclipse based IDEs, it will first ask you to open the workspace. So here we don't have workspace in it. So workspace, remember, is collection of projects. Now first we have to create a workspace. Now let's create one workspace. Now in my D drive, under workspace directory, let me create one folder. I will call it as, you can create anywhere you want. So I will call it as STM32 System Workbench Workspace. Great, so this is my workspace where I keep all my projects. Now let me just open this. Now let me just copy this path and let me just put here. Alright, so now let me just click OK. Great, so here you can see that a workspace being created at this location. So now here you can see that Eclipse has created a workspace, and here is a workspace name. And now let's enter into that workspace. Let's click here. So we just entered into the workspace and there are no projects because we have not yet created any projects. Alright, so now in order to get introduced with System Workbench software, let's create a project. Now let's take the help of STM32 CubeMX software to create one or two projects. So just to get introduced with this IDE. Great, now let me just open my STM32 CubeMX software. It must be under ST Microelectronics Cube, and here it is. Great, so now the STM32 CubeMX software has launched, and now let's create a new project. So just click over here. So alright, so now it is checking for some updated files. Just wait until it finishes that. Alright, so now here you have two options. One is MCU selector and another one is board selector. Now remember that if you are using any custom board based on STM32 microcontroller, then you can go for MCU selector. But in this course, since we are using a standard board from ST, that is, it may be STM32 discovery, evaluation, or nucleo boards. Since we are using standard boards which are produced by ST, you can go for board selector. So now here when you click on board selector, you will find a couple of options here in order to filter your board. So you can just select discovery and it will list out all the discovery boards which are produced by ST. Here you can see, and if you still want to filter, then just type the board name. Let's say if you want to locate STM32F4 discovery, just type STM32F4 discovery. Here it is. Just select that and here it is. And if you select that, it will give all the details regarding that. So if you just click over here, it gives all the details regarding this board, and here you can see that all these are features of this board. And if you are having a nucleo based board, and just type the board name. So suppose, let's say I am using STM32F446RE nucleo board, so I would just type F446RE. Here it is already listing it, nucleo F446RE. so that's the board name. So let me select that, and here it is giving all the details regarding the board. And if you want to create a project for this board, then just double click on this board picture. So now let's double click on that, and here it is. Now it is asking initialize all peripherals with their default mode. Now this is very important option. Here basically the QMX software is asking you whether to initialize all the peripherals which are there on this board design. So because the board may be using couple of peripherals, isn't it? For example, the board may be using some UART peripheral in order to talk to the PC, right? So that we call as virtual COM port. All right, so because when you connect a nuclear board to your PC, the PC will detect it as a virtual COM port, isn't it? So how that is possible? So that is possible because of virtual COM port support, as well as that interface is utilizing one of the peripheral of the microcontroller, that is the UART peripheral. So basically this option is asking you whether to initialize all those peripherals or not. I would click no here if I'm using custom board, but I would like to click yes here since I'm using a standard board which is produced by ST. Okay, so let's click yes. Alright, so just wait for a moment so that it can open the project for the selected microcontroller and board. Here it is, and here you can see that it has initialized some of the pins as per the board design. Alright, so when you first created a project on STM32 QMX software, then remember that you have to save that project. So for that, just go to project and then go to settings. Here it is. Alright, so here there is some old path. So now let's go to our project workspace path, so which was this one, isn't it? So here let me just copy this and let's paste here. Alright, so now here give a project name. So now let me give it as LED toggle, and let me give the number for the project, let's say 001. And here you can see that under that path, this folder will get created automatically. Great, so this is a project name. Now toolchain and the IDE. So the IDE we are using is this one, SW4 system, SW4 STM32. So that's actually our system workbench. So select that, and after that take a look into this option here. So here it is basically saying use default firmware location, and this option is basically pointing to the latest firmware package which is available when you downloaded and installed this STM32 QMX software. So for me it is showing 1.21, so that was the latest version at the time of making this video, and for you it may be different. Now make sure that this and this actually they are pointing to same firmware version 1.21. Now let's go to code generator, and basically you need not to do anything here, so just observe this, so don't change anything. All right, great. Now let's go to code generator and make sure that this option is selected, and that's it. Just click OK. Fine, so you have saved your project, and this MCU, as I said, and here you can see that some of the pins of the microcontroller is already initialized. And take a look into the LED pin here. So PFI is actually a GPIO which drives the green LED which is there on the Nucleo F446RE board. So for your board, if you are not using Nucleo F446RE, it may be different. A pin which is driving your LED may be different. Don't worry about GPIO and other details regarding the microcontroller. So we will learn everything from scratch in this course. So I will teach you what exactly is the GPIO, what are the registers which are governing that GPIO, what is the GPIO port, how to configure it to drive LEDs, what are the different modes, input mode, output mode. So everything we are going to learn. So this lecture is basically to understand working with STM32 System Workbench. That's it. Here, as I said, PA5 is actually initialized, and it is currently driving the green LED. Great, so that's what we wanted. Now just go to project and then generate code. Click on generate code. So here it is. So here don't click on open project, click on open folder. Great, so here it is. So this is our workspace, isn't it? And this is our project, right? Great, so if you just go one step back, so here it is, there is a project. Now let's import this project to our workspace. Our workspace is currently empty, isn't it? So just go to file and then click on import, and here it is. Go to general and existing projects into workspace. So click over this option, click next, and then give the directory. So this is a directory, isn't it? That one project indeed exists. So let's copy this and paste here, and then click on browse. So when you click on browse, here you can see that the Eclipse engine has already detected that yes, one compatible project is exist, and it has already checked that. And now don't click on any options here, let it be as it is. Just click on finish here, and you just imported your project. Great. And now let's build this project. So here it is. This is the main code which does lots of things, like initializing the microcontroller and initializing the GPIO and then initializing various other things. So let's not worry about all those things. Now let's just write a simple program in order to toggle the LED.